Falcon Heavy is a two-stage launch vehicle. The big difference, of course, is that the Falcon Heavy first stage is comprised of 3 cores, and Falcon 9 only has 1. Each one of these cores has 9 Merlin 1D engines, making for a total of 27 engines overall, as you can see on your screen. Now, altogether, these engines produce over 5 million pounds of thrust, equal to 18 747s at takeoff. In fact, the engines produce so much power that we don't run them at full thrust all at once until after liftoff. For the mission today, each one of these 3 Falcon 9 boosters is brand new. It's also going to be the first time we are flying Falcon Heavy with our upgraded Block 5 cores, which feature more lift capacity, a beefed-up heat shield, and other changes to make the boosters more reliable and easier to reuse.
During ascent, Falcon Heavy will throttle its thrust up and down on both side boosters and the center core to balance aerodynamic and structural loads on the vehicle. About 70% of the way through the first stage burn, the 2 side boosters will separate and come back to Earth for a simultaneous landing at Cape Canaveral Air Force Station on Landing Zone 1 and Landing Zone 2. At this point, the mission will proceed just like a standard Falcon 9 flight. The center core will keep firing for another minute, then we'll perform a standard stage separation from the second stage. We will attempt to land the center core on our drone ship, Of Course I Still Love You, which is currently stationed about 535 nautical miles off the coast of Florida in the Atlantic Ocean. It's worth mentioning that for this mission, bringing back the center core is challenging. If we are able to land all 3 cores tonight, it will be particularly exciting. The second stage is exactly the same as any other Falcon 9 flight. Tonight, the second stage will be sending our payload to geosynchronous transfer orbit. The spacecraft will then maneuver into a geostationary orbit more than 20,000 miles above the Earth's equator. Now, to put that into perspective, that's equivalent to almost an entire trip around the world traveling along the Earth's equator.
Speaking of the satellite, it is safely enclosed inside the 17-foot diameter payload fairing, which is the pointed cone on the very top of the rocket. This protects the payload from aerothermal loads, heating, and contamination during ascent. Now, once we reach the vacuum of space, we will jettison the fairing as the second stage continues on its journey to orbit. While Mr. Steven, our ship, will not be supporting today's mission, we do plan to recover the fairing pieces from the ocean using our recovery ships Go Searcher and Go Pursuit. And lastly, you'll notice the tall structure next to the rocket, which we call the fixed service structure. Its primary function is to provide passengers access to the Crew Dragon vehicle during crewed missions. But since we do not have any passengers aboard today's flight, the fixed service structure does not have a role to fill. Now let's check in on how the countdown is going.
Good Thursday afternoon. I'm John Innsbrucker, the Falcon Principal Integration Engineer at SpaceX. We are T-minus 10 minutes, 28 seconds from the launch of the Falcon Heavy. As I like to say in my updates, the SpaceX team is working no significant issues and is on time for launch. Now, Falcon Heavy rolled out to the pad with the payload early Wednesday morning and went vertical about 6 hours later. Now, after yesterday's scrub, the vehicle remained vertical on the pad. The pad deck was cleared at about T-minus 8 hours to begin today's hazardous operations. Just before we began the webcast, the SpaceX launch director polled the 9 members of the launch team and got a go for both propellant loading and for launch. Now, we're currently loading propellant on all 3 first stage boosters and the second stage. Now, our propellants are an oxidizer, liquid oxygen, and a fuel, kerosene. Why did we pick these 2? Well, obviously in space there's no oxygen needed to support combustion. So we bring our own as liquid oxygen. It's readily available and it supports efficient combustion. We chill it to get it as dense as we can in order to maximize how much we can load onto the rocket. Our fuel is RP1, essentially a purified kerosene. It is safe, so we bring our own as liquid oxygen. It's readily available and it supports this very pad on the moon missions used liquid oxygen and kerosene. Now on the spacecraft side, the Aerosat 6A team began transfer to internal power T-minus 21 minutes, and just a few minutes ago they completed that. They are go for launch. Now for tonight's mission, we're using the Falcon Heavy to place the satellite into an orbit with an apogee near 90,000 kilometers. This is much higher than the apogee of a normal geotransfer orbit. With this higher apogee, it is more efficient for the satellite to maneuver into its final geo orbit. The range is currently green. They are prepared to support today's mission. And for the weather, the good news is the upper altitude winds are much lower today, so both ground level and upper altitude winds are go for launch. No worries there. Now, as Jesse mentioned, we did start the day with a 2-hour launch window. However, now that we are into LOX loading, we don't have the ability to hold the countdown. If there is an issue in the last minutes, there isn't enough time in the window to stop, reload the cold liquid oxygen, and still launch today. There is a backup date, though, this Saturday, April 13th at the same time. Now, as I've said before, launch is hard, and Falcon Heavy is no exception. We are essentially counting down 3 rockets simultaneously. So the SpaceX team is going to be conservative in case anything pops up in the last minutes. But as the energy from the team gathering below me outside of the Mission Control Center is growing, we are go at T-minus 7 minutes and 20 seconds.
As we mentioned earlier, the payload being launched tonight is for our customer Arabsat, one of the world's top satellite providers in the Arab world, reaching tens of millions of homes in more than 80 countries. Arabsat 6A, which was built by Lockheed Martin, is a high-capacity telecommunications satellite that will deliver television, radio, internet, and mobile communications to customers in the Middle East, Africa, and Europe. Here's a quick message from our customer.
One world, one heart. A world so different, yet so alike. Our world. The one and only world where we feel more at home. A world that's growing wider than ever, with more choices and more possibilities. The world of Arabsat, the largest Arab community in the sky, now closer than ever, with the new generation of Arabsat satellites. Welcome to our neighborhood.
First light the 2 side boosters, and then fractions of a second later, the center core. The flight computer on Falcon Heavy will check power on the 27 Merlin 1D engines, then command release from the ground hold downs at T0. 40 seconds into flight, we'll decrease power on the 2 side boosters in preparation for maximum aerodynamic loads on the vehicle. Once we get through this period, Falcon Heavy will throttle back up to power on the side boosters. Once we get 2 minutes into flight, we will again reduce thrust on the 2 side boosters. At this point in time, the vehicle is much lighter, having burned much of the propellant, but the thrust is constant, so the acceleration, hence the loads, are continuing to increase. So we will reduce thrust on the side boosters to decrease forces on the rocket structure. When we get 2.5 minutes into flight, we'll fully turn off the side boosters, an event called BECO, Booster Engine Cutoff. The pneumatic separation system on the center core then unlocks the 2 side boosters and pushes them away. You've just heard the call out. They're going to begin retracting the clamp arms as part of the TE Strongback retract sequence. Meanwhile, back in the ascent sequence of event, once we get the side boosters separated from the center core will throttle up to